All right, so today we're going to take a look at a few more transformations we can make of trig functions. We looked at translations yesterday where we moved things back and forth and up and down. Today we're going to take a look more. So here's our general equation, and we can change things by moving them back and forth, moving them up and down, which we looked at yesterday. And today we're going to look at how we can stretch or compress them horizontally, and how we can stretch or compress them vertically. So here's an example of one. This is looking at an a value of 2. So we start by graphing our 5 points. Then we're going to double the y value in each of the cases. So the zeros aren't going to change, but the 1s are going to become 2s, and negative 1s are going to become negative 2s. So we end up with these points here, the blue ones. And then we're going to draw our axes. It's right down the middle where those 3 points are. And then we sketch our graph using those points as a guideline. And there we go. Okay. So it's exactly the same as the other graph, except, or the straight sine graph would be, except it's twice as tall. Its amplitude is 2. Our a value gives us our amplitude. So the axis of our graph is y equals 0, our amplitude is 2, and our period is still 360. We haven't changed the period at all. All right, so here's another example. Graph y equals cos of 3x. Okay. So we're going to graph our points to begin with. There they are. Okay. And now what we're going to do is, because there's a 3 beside the x, that means there's 3 full cycles in 360 degrees. So our period is 360 degrees divided by 3. So we can see here there's one set of blue dots that are in 120 degrees, 360 divided by 3. We can continue on and fill up our whole 360 using the exact same pattern, just so we see how it moves up and down. Our axis of our graph is going to go right through the middle. And then we're going to use those points as a guideline, and we're going to draw our graph, and then we can extend it out back both directions. So we end up with a graph like that. Notice our amplitude is still 1. What's changed now is our period. Our period is 360 degrees divided by 3, so 120 degrees. Okay, so if it's right beside the x, if multiplying the x, okay, it's going to divide the period, and that's how many times it's going to go up and down in 360 degrees. And if it's out in front, okay, it's going to then make it taller. All right, so here's one that has both of the pieces in it. It has a 3 as the a value out in front, which would tell us that the amplitude should be 3, and it has a b value of 0.5. Okay. Now, since it's a fraction, or less than 1, that means that our period is going to be bigger. Okay. So that's multiplying by a half, okay, which is making our period twice as big. So if we take 360 and divide it by 0.5, we end up with 720. So graph our points to begin with. And then we're going to change our period. We're going to do 360 degrees divided by 0.5 to get 720. So we're going to space our dots out so they're twice as far. Okay? So instead of hitting at 90, it's going to hit at 180. Instead of hitting at 180, we're going to do 360, and so on. Now, that's the first part. The second part is to change using our a value. Our amplitude is going to be 3 times as high. So now we're going to, anything that is up 1, we are going to put up 3. So over here, you see it's a 1. We're going to multiply it, so it's going to be up at a 3. This one's not going to change because 0 times 3 is nothing. This is 1, so it's going to go down to a 3. 0 is not going to change. Okay. And 1 here is going to go up to a 3. Okay, so there's what our dots look like. We have a 3, a 0, a minus 3, a 0, and on the edge here you can see the 3. So there's our dots. Our center line is still right down the middle here. Okay, between the maximum and the minimum, halfway through is our center line. So draw our axes in so we know where we're going up and down around. and then we can sketch our graph going through the points. Okay. You'll see that it goes one full cycle in 720 degrees. Okay, so the period is 720 degrees. If either A or B is negative, the graph is reflected in the x-axis. So here's an example of y equals 2 sine x. We can see that its period is still 360 degrees because there's no number in here with the x. But its height is twice as high as a regular sine function is because of the 2 out front here. If I make this number a negative number, it's simply going to flip everything over. So instead of going up to start with, it's going to go down to start with. Instead of this being a positive 2, it's going to be a negative 2. So we're going to end up with a graph that looks like this. And if we're going to take a look at the b values, here's the two graphs. Okay, we can see, there we go. All right, don't know where my pointer is, but okay. You can see that the blue graph goes up and down, starting going up, so it's a positive number. Okay, and there are 3 cycles in 360 degrees. And the blue graph starts by going down because it's a negative 3x. So it's the opposite of what the sine function is. And you should make note that sometimes there's more than one way of writing the formula for a sine or a cosine graph because we can flip it or we could move it left or right and they would give us the same thing. So for example, y equals sine of negative 3x can also be written as y equals sine 3x minus 30. So sine 3x all shifted 60 degrees. I think I said 30 degrees, so 60 degrees. Okay. So just be aware that sometimes you can get more than one answer. So if your answer doesn't line up with what my answer would be in the solutions, graph it using Desmos and double check to see if the two functions are the same. A lot of the times they are the same, and I can't write every possible answer down. So make sure you check it with Desmos if you're not sure. So I'd like you to try the homework now on U7A3.